The definition of an ellipse is in section 10.3. If you have one focus point right here at C0, you have one focus point here at negative C0. Those are the two fixed points in a plane. And A is a constant, and this is A. From here to here is A. That's A. Then a set of all points P in the plane such that if you go from the focus point to any point on the ellipse back to the other focus point, so go from a focus point, any point on the ellipse, back to the focus point, the length of this is 2 times A. So in this one, A is 5, so this length is 10. Okay? The fixed points are 4, 0, and negative 4, negative 4, 0. And those are the focus points, or the foci. That distance is 10. And it doesn't matter where you do it. I could go from here, over to here, back to there. Does not matter. Here is the equation of an ellipse. If the ellipse is elongated parallel to the x-axis, it would be x squared over a squared plus y squared over b squared is equal to 1, where b squared is equal to a squared minus c squared. So this distance right here is A. The distance to my focus point is C. So the distance from here to wherever the focus point is C. The longer axis is called the major axis. So this right here, 5 squared, would go on the bottom under the x squared. The center point is 0, 0. The minor axis is the shorter axis. And from the center up to the ellipse, or the center down to the ellipse, that distance is B. So this ellipse has a major axis parallel to the x-axis, making it open longer across. It's elongated that way. The length is 2A. That's 2 times A. The minor axis is parallel to the y-axis, and it has a length of 2 times B. The focus points are 2 C units apart, because one's C to the right, one's C to the left. The center of the ellipse, until we translate it, but this center will have a 0, 0. We will translate them also. The vertex points are the end points of the major axis. So the vertex, these are the vertices. Right there's a vertice, and there's a vertice. Okay? Remember, that's bigger number. A squared will be bigger than B squared. If it is elongated up and down parallel to the y-axis, it has the equation of y squared over a squared plus x squared over b squared is equal to 1, where again b squared is equal to a squared minus c squared. Same idea, except now here's my major axis. From here to here's A. This distance is C. That distance is B. Small axis, minor axis, longer axis, major axis. Okay, so they're reversed. Okay, and now the larger value is under y squared instead of the x squared. So let's sketch a graph and find the vertices, endpoints of the minor axis and the foci points for x squared plus 4y squared is equal to 16. Let's look quickly at the equation. It has to equal 1. So let's get this equation equal to 1. So if I divide everything by 16, I will have the correct form. So there's my correct form. The larger number is under x squared, so a squared is equal to 16, and b squared is equal to 4. So that makes a equal to 4 and b equal to 2. You can use this equation to find c. So you could do b squared is equal to a squared minus c squared. Solve it for c squared, so 4 squared minus 2 squared. 16 minus 4 is 12. The square root of 12 is about 3.5. This ellipse has a center at 0, 0. So my center's at 0, 0. Here's my center. And I go A units over, or A units over this way, and this will take, and remember what A was? Better graph right here. A units over here, or A units over there, took me to the vertices. Okay, so A is 4. This is also 4. Okay, so I have vertices then at 4, 0 and negative 4, 0. The endpoints of my minor axis, I would go up the square root of 2, so I would go up 2, or I would go down 2. Right there is 2. And that would give me the endpoints of my minor axis. So that would be 0, positive 2, and 0, negative 2. The focus point would fall along the major axis, and they would be about 3.5 units over. So they would be at 3.5, 0, and negative 3.5, 0. And I kind of said it, so let's graph it. I kind of almost did the graph up there. So here's what I said. So let's graph it. Center 0, 0, 1, 2, 3, 4. 1, 2, 3, 4. 2, 2. And then when you graph it, oh, and if I want you to graph the focus, you can graph the foci also. And when you graph it, just do, it looks about like an egg. And I'm not an artist. I don't expect you to be an artist either, okay? So there. And you're done. An ellipse has a center at the origin. Find the equation of the ellipse with a vertex of 8, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 0. My center is there. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so when you're doing this, A is the distance from along the major axis. That's my distance A. So that is 8. Okay. It said my minor axis is 4 units long. So if it's 4 units long, I know that it has to be right there. B is 2. Okay. A squared is the denominator for my x squared, because that's the major axis is horizontal. Okay, so when you do the equation, you have x squared over a squared. Then you have, I should have it written here somewhere. There it is. Plus y squared over b squared is equal to 1. So there it is. Done. An ellipse has a center at the origin. Find the equation of the ellipse with a vertex of 0, negative 12, and a focus of negative 4. So 0, negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So 0, negative 12. 0, negative 12 is my vertex. I have a focus of 0, negative 4. 0, 1, 2, 3, 4. That's my focus. So hopefully now you're looking at this and saying, okay, the vertex has to be an endpoint of the major axis, so now my major axis goes this way. Okay? So I know what A is. A would be positive 12. And C is positive 4. Because the distance from center to the focus is the C, distance from center to the vertex is A. And like I said, both are on the y-axis, so the major axis is vertical now. So A squared now is the denominator for y squared. But to find B squared, we can use the equation. A squared minus C squared. So I have A squared minus C squared. So B squared is 128. So my equation then ends up to be y squared over A squared, x squared over B squared is equal to 1. And that's what I have there. And if you want to put your x squared first, you can. Doesn't matter. And you're done. Translations. Now look at the only difference. My center now is not 0, 0. My center will be HK. H is with the x, K is with the y. So that's the only difference now. You're going to do the same thing. You're going to find the center. You're going to either go along the major axis right and left, or along the major axis up and down, and figure out what A, B, and C are, and then you will have your equation. Or you'll have your graph. X squared, larger number under it. So since the larger value is under the x squared, the major axis is a horizontal. A is the square root of 25, which is 5. B is the square root of 16, which is 4. And then if you use the equation, B squared is equal to A squared minus C squared, you will get 3. The center is at 2, negative 1. Okay? So now let me just graph a little bit what I have. I have a center point at 2, negative 1. And I said my major axis is horizontally. So if I go A units this way, or A units this way, I will be at the vertices. A in this equation is 5. So to get to the end point here, if I go 2 over and 1 down, I'll be at this point, but instead of going 2 over, I'm going to go 2 plus 5 over. So this point is 7, negative 1. Subtract 5 from there is negative 3, negative 1. Okay, I was going right and left, so that's the x. I'm adding and subtracting 5 to and from the x value. The minor axis is B away, so I'm going to go up and down. So B is this way. Okay? And that's with the y-axis going down and up. And B is 4. So if I go down 4, my y value is negative 5. If I go up 4, my y value is 3. So I'm at the point 2, 3, and 2, negative 5. Okay? The focus points, going this way, C over. Okay? So add or subtract from my x value, C units, and C is 3. So 2 plus 3 gives me 5, negative 1. 2 minus 3 gives me negative 1, negative 1. And I would have been sketching this as I was going along, because I kind of did up here, but I didn't have enough room to do it. So let me just do the quick sketch. My center is 2, -1. So there's my center, 2, -1. And vertices, 7, -1, 2, 3, 4, 5, 6, 7. And -3, -1. This distance here is 5. Endpoints of my major axis, 2, 3, 2, 5. And make sure you're doing this right too when you're graphing it. Make sure 1, 2, 3, 4 units, 1, 2, 3, 4 units, okay? And the focus points will be 5, -1, 4, 5, -1, and -1, -1. So just make sure it's nice and symmetrical, and then graph it. Like I said, I'm not much of an artist, so try to do it as best you can. And there's the graph. Find the equation of the ellipse with a center of 2, 5. So my center is 2, 5. My center. One focus is 5, 5. And one vertex is 7, 5. Okay? So now when you look at that, you should say to yourself, oh, the horizontal, the major axis must be horizontal because the vertex and focus are on the same line. So my major axis this unit right here, from here, 2, 5, to the point 7, 5, is 5 units away. So if I go 5 units away this way, if I was going to graph it, that's what my A is. A is 5, major axis, and it'll go under the x squared. So let's start doing this. The focus and vertex are the same horizontal lines. A is the distance from the center of the vertex, so A is 5. C is the distance from the center to the focus point. So from here to here, from 2, 5 to 5, 5, that's 3, so that's what C is. And remember the equation, b squared is equal to a squared minus c squared. So b ends up to be 4. Or b squared is 16, okay? So the equation is x minus h, and h is 2, so x minus 2 here. Y is 5, so it's y minus 5, and those quantities are squared. A squared goes under here, so 25 goes under here. B squared goes under here, so that's 16. Done. The homework for this section is 1 through 33, every other odd, and then also 35, 39, 43, 47, 51, 53, 54, 55, 57, 65, and 67.